All right. What's going on? Rolling solo here today. What's going on, Lee? Good to see you. Frederick, what's going on? Thanks, dog. Super chat, rock and roll, hack. What's up? Nikki, Red Sky, how you guys doing? Just checking in here on Friday, February 24th to see what is going on. We got I don't know, a bunch of stuff going on this week, right? We had the most recent thing is this, I'll drop it in the chat here. Try.heliumsim.com. So if you've got a Helium 5G or CBRS radio at your location, you can start to use it for your phone. I put one of these things on my phone last night, and yeah, seems to work. Pretty cool. Just got a regular old iPhone, and it picked it up nice and clear and strong. WTV Siegfried, what's shaking? All right, like the new thumbnail, cool. That was the yeah. I was messing around with Dolly or whatever it is. It's like Beta Open Labs or labs.openai or something. Helium Kenny, what's going on, man? I think Helium Kenny, you missed the coffee cutoff this week, so maybe I'll have something next week. Russ, what's shaking? Good to see you on here. I think we're gonna have Paul join us a little bit late to talk about Greg. What's going on, dog? Good morning. We're going to have Paul talking about IoT devices, which is probably the second big piece I had today. Talked about this with the Gristle crew earlier this week, but the whole 3D printed housing for the soil moisture sensor. Get that going. I just put out the first video in that series yesterday on the local nursery. Yeah, that's allowing me to like basically do whatever it is I want as far as sensors on their nursery, and it's been super fun to. You did miss the cutoff, yeah. It's been super fun to kind of figure out with them what sensors they might use. It was, I think that the strategy on these things is to go in with one sensor that you think is kind of useful. In this case, it was a soil moisture sensor. I've got them behind me, otherwise I'd grab one. And say like, hey, I've got this thing. I think this can help. What do you think? And then to go into, hey, like what else could you use? Because what I found out of that was that yeah, they wanted this. They want to measure how much diesel's in their tank. They want to measure how long their machines have been running. What's up, Kevin? They're interested in the water leak stuff, but they didn't seem to care about it as much as I thought they would. And I think on the water leak side, there's a pretty interesting piece in that water flow meter, which is what you'd want to put in to get really accurate measurement of how much water is flowing through a pipe and therefore kind of leaking, because they got pipes all over their property. It's either 40 or 80 acres. It's probably more important for like, so a water flow meter is pretty expensive. So I was thinking, well, I can just use these cheap soil moisture sensors. They're $20, plus I don't know, $1.50 for the print, the 3D print to print it out. So $21.50 each, and put them right underneath where the leak is. And then once the soil gets wet enough there, there's a leak, instead of a $200 water flow sensor that would give you a more accurate understanding of how much water is leaking. But yeah, so just kind of interesting stuff, cruising around checking that stuff out. Yeah, I think that's most of what I got for this week. I'm sure it'll shape up. If you guys have questions, I talked to Bobby Goaltender last week about coming on. I don't think I heard back from him. Maybe I did, but I don't see it in Discord where he came back. So see what's going on there. And then what else is going on? I'm looking for the kind of next project to figure out on Helium. And I think there are a bunch of these sensor projects for this nursery. And that seems pretty straightforward, is just find the sensor, find the problem, figure out how to fix it, and then go from there. But the 3D print piece, which I'll release a video on, I think this weekend, like how I did it, how I found the guy, the problems we had, all that stuff, was fascinating. And I think there's so much room in this space to figure out a new kind of 3D housing for something. I think there's actually a fair amount of power in figuring that out, and then figuring out what the sensor is that you're going to put all that stuff in. So kind of going backwards about it. I think there's potential in this weather station idea. I can't find a weather station that meets my criteria, which is that it's got no moving parts. And it also has PM 2.5 and PM 10, which are particulate matter, which is a check. What's up, Jay? Check of how clean the air is. I think WeatherXM has got a great weather station, just kind of standard use, but it's got moving parts. And I'm going to be putting these things up on land where there's just got permission to put them there, but there's a lot of people who go on there who will just smash anything they see. What's up, Bo? Maybe, Bo, we can talk about Deep Insight. I don't know if that website is ready to go yet or not. If it is, I will pop it up here. I haven't even seen it. I've just seen the URL and that you guys are launching it. I know we're talking a little bit later today. So, yeah. Where is Bobby? What's up, Dumpling Girl? Kyle, what's going on? Keenan got me oh, shit. I think it's all got to get washed, but I got, I threw it in the laundry for a first round. I got all the Keenan's Helium swag came in. So I got a bunch of different t-shirts, hats. Is there a hat in there? Yeah, because Lee immediately stole it. There's a rad little coffee cup, stickers, and a bunch of patches. So super cool to get that. I should have those up and running for the next show, but the 𝗚𝗿𝗶𝘀𝘁𝗹𝗲 roofs for HNT stuff is out there. So that's pretty cool. God, where was I? I think I was talking about sensors. Oh, I was looking at, what was I was looking at these weather stations and looking at all these different things. What's up, Paul? Yeah, show us the swag. Should I go dig in my laundry bin to go dig out the shirts? Because I was like, oh, I'll wash these so they shrink to the correct thing, correct size before I put them on. I can go dig them out. My mom's staying with us, so she's taking up the laundry room right now. It's now the guest room, so all the laundry baskets are in my office. So I can go grab them. Paul, if you want to come in and talk about helium, sorry, what is it? Secure concentrators. I'll throw you a link in Discord. If you're into that. I'm not sure what the latest is on that. I think the last call is that there's just progress, but if there's something big and new, let us know. Let us know. Come on. Pull it out of the wash. Yeah. All right. Yeah, so the weather station thing, I saw there is a weather station being sold to, looks like the U.S. military, and brace yourselves, it is $7,000. I think it meets most of the requirements I've got, but a $7,000 weather station is not what I'm looking at. And so I was just kind of thinking, okay, well, I got so excited about working with this 3D designer that I found on Upwork, 3D print designer I found on Upwork, and just thinking about like what I want. I think there's like, this is the time if you are doing helium stuff to be putting out sensors. I've got a couple companies sending me sensors that I'll be showcasing in the next couple weeks. 𝗚𝗍𝗁, ELSYS is sending me some. The Gristle crew remembers them from the call we did with, what is it? How am I blanking on this thing? Bill from Novacine, who also presented in London when we did the Helium in the Wild tour. But Bill had kind of alerted us to these things or clued us into these things, or indoor CO2 sensors. Super cool. And so, yeah, mil-spec hack it, a $7,000 weather station, and things like this big. And so here's the crazy thing with weather stations is they've got to face a certain direction. So they got to face north. They've got to be up high enough to get. Well, actually, no. Depending on the height they're at, they will read significantly different wind directions. And so I don't know if I did a video on it or if I just did a picture of it and put it on Twitter. But I've got that 𝗪𝗁 6000 up on the roof, the one that I won at CES. And then about 15, maybe 18 feet higher than that, I've got my WeatherXM, the non-helium station, just the regular WeatherXM station. So it's connected into the Wi-Fi. And they will read wind directions that are 30 degrees different. And it's because there's I think it's because there's a tree down low. And maybe it's also my neighbor's house. The roof is at the 𝗪𝗁 level. And so it creates this wind turbulence or swirl that changes the wind direction significantly. So pretty interesting to think about, like, how do you make sure a weather station gets put in the in the right place? It is like a $9,000 hammer. Or what was the other one? The NASA toilet seat thing that was like a $30,000 toilet seat back in the 80s. $7,000 is cheap for government work. I mean, so here's what I think. I think that I can put together a weather station for $200 that hits all the things that I want to do. And I've been talking very, very casually. In fact, I'd be surprised if most of them have heard about it. I've been talking with Lena, and maybe I talked about it with, is it Manos a long time ago, about doing a weather station for WeatherXM. So I think there's an opportunity for WeatherXM to open up a HIP 19 kind of thing for their stations and allow other stations to come on there. That's just what I think. That may not be what they think. But I think it'd be pretty cool to be able to design a weather station that did what I wanted, and then get it onto the WeatherXM network. So rather than weather balloons. Yeah, I think we've seen a lot of balloons lately in the news. What is that super cool one? Kanda, Kanda. That is those guys have been releasing weather balloons to check the I think it's called atmospheric sounding. So all across the world, there are balloons released every day with the sensor package on them that go up into the atmosphere, and they measure the temperature and humidity and pressure and all this stuff at different levels, and they give us an idea of what's going on in the troposphere that day. And tropo is change. So it's kind of the changing weather part of the Earth, which if you ever look at the Earth from a wide view, it's pretty rad to see just how thin the layer is that changes and also that protects us from space. All right, Paul, let me get you a link to this thing. I think you've been on before, but let me just copy it and I'll drop it into Discord. So for you guys watching this, my eyes are going to be going all over the place as I track down Paul and get him the link. There we go. To jump in. Okay. Cool. Dynacore, that just went out to you. Yeah. So kind of all over the place here on the weather station thing, but I think the bigger thing is looking at all of the mappers that are out there. I think there's also potential for a pretty cool 3D print for a mapper, and I have no idea on the details, but my gut is telling me that like a redesigned mapper case with maybe a little bit of extra functionality. And Gray Hat, Jason, I know you've been doing a bunch of work on those things. What's up, Paul? Let me see if I can bring you in. Is that there's potential for that to go. Let me change this over to SOT 2. You don't need to see me twice. Let me pull in Paul. There we go. Paul, what's going on, dog? Enlighten. I think you're muted, but I'm not sure. Because I can see you. I just can't hear you yet. Guest has muted themselves. Yeah, you may have to figure that out. But we'll get it. We'll get it. Yeah, I can talk about weather station stuff until you come on or drop out. And I think the other thing, Paul, is if you're watching this, is that this thing only likes Chrome. I guess I'm my own guest here. You guys are seeing live action on getting this thing working. The software is Ecamm Live. Works really well with Macs and Chrome, but other stuff it can be a little bit of a pain in the butt or just kind of fiddly. But yeah, super easy. We talked about Kanda. We talked about the balloons that they are releasing into the troposphere every day. How's it doing this time, Paul?
All right. What about now?
Yahtzee. We got it. 5x5. Dude, what's going on? What's the latest on secure concentrators?
I am working every day, pretty much.
Okay.
My nighttime job is this,
Yep.
and just writing firmware, working with the Helium Foundation, Jeremy and Sophie.
Yep.
Just having conversations and trying to kind of craft the hip and make sure it's ready to go. So very excited. Slow and steady progress.
Yeah. I just talked to, I think, Jeremy and Sophie. They're in Denver for something the other day. Soph's coming into San Diego today. I'm super excited to see her and get to hang out. And Jeremy, I'm going to see in a month and a half. We're doing a canyoneering trip in Utah together. So be rad to hang out with them. Hopefully by then he can take a week off so this thing is ready to go. So what are the big difficulties with secure concentrators, and then what are the big benefits? I know you and I have talked about this before, but it'd probably be pretty cool to go through it on State of the Network here.
Yeah, let's see. Difficulties. Well, it's hardware, and it's basically the way the hardware is designed puts the microcontroller in the middle. It's basically a man in the middle between the host CPU and the network chip, the thing that actually receives data and sends data. Okay. And that's important, I think, for security because it basically guarantees that any data coming in or out of this thing can only go through the secure concentrator. So that's good. The downside of that is it involves some pretty good, hefty, secure firmware. there's some kind of real-time processing requirements here, some crypto security stuff. So yeah, so it's a fun and interesting project.
Yeah, and it's taken. I mean, you've been working on this for a while now. I think we did a show in like September, and you've been working on it for 6 months before that, or maybe more.
Yeah, yeah, I've been banging away at this for I think well over a year. And it's all this. I'm able to do this
Yep.
from the generous uh, Helium grant that I received, which is awesome.
Yep.
So big shout out. I heard yesterday. Was it yesterday? I don't know.
Yeah. Yesterday, the day before they reopened.
Reopened the grant project. So
Yep.
dream big. You can apply for a grant, and you know, uh, if if it if it kind of fits the helium use case, I think people will go for it.
Yeah.
So very
Super cool.
awesome.
What let's see, you and I had talked a while ago about getting the things made, because there's definitely a money part to this.
Yeah.
And I know that when I went up to do the Hive Mapper thing, I talked to the guys at, it's not they're gonna kill me, it's not Snot Rocket, it's Hellbender. So Hellbender
Yes.
is like a salamander on the somewhere in Pennsylvania, and the local term for it is Snot Rocket. But the Hellbender is also the name of this company that does these chips. And I remember talking to them. They're talking about spins, and it's like $1 million to do a spin, and that means making a bunch of chips. And I'll get half of this terminology wrong, and Jason over at Grey Hat Guy will be like, "Dude, you're butchering this." But it's not like you can go out and buy a $20 kind of one-off board for this thing. You've got to make a bunch at a time, right?
That's right. I mean, with pretty much any custom electronics, it's like it's all about the economics of scale. The first like 50 of building a new PCB is very expensive.
Yeah.
And then
What's very expensive? What does that look like for per unit? It's like $1,000
um,
per chip kind of thing, or
well, I mean, it's all depending, right?
sure.
The secure concentrator project is well over $200 for per board
Okay.
in quantities of five. So I did my prototype run of I just had five built,
Yep.
and it was very expensive just for those five because you're paying for the labor for someone to program the pick and place machine,
Yep.
um, and that's a lot of upfront cost.
Yep.
Um, but all those for the most part, those are kind of just like one-time fees, right?
Right.
Once you have someone program that, then it doesn't matter how many boards you're doing. You could do two, or you could do 200 or 2000. Like you don't need to change the programming. And so that's
Right.
kind of like one example of the economy of scale there. Um, Same thing with buying parts, like the discrete components, the passive components that go on the PCB board.
Yep.
Um, there's a huge economy of scale there. Um, so yeah.
Okay.
So
So the first five were $1,500, something like that, maybe a little less, a little more, shipping, some other crap in there. I mean, that
yeah.
seems reasonable, because I was thinking more like it's going to be $1 million, and I didn't see an easy way to get there.
No, right. So that's kind of like challenge number one
Yep.
is, you know, if you're just kind of doing a hobby project and you just want to get five prototypes built just to kind of do the proof of concept, you still kind of need a decent amount of cash, like, a couple thousand.
Yep.
Um, and then, so that's, challenge number one. And then when it becomes production time, that's a whole nother set of challenges. It's very different going from building five of something
Yep.
to building thousands of something.
Right.
Um,
And it's
so
going to take
yeah, so
thousands of these things to make a difference, right? To kind of do the thing that we want it to do.
yeah, I've talked about this before, and Jeremy has as well. Kind of this idea of peppering the network with secure concentrators. It doesn't
Yep.
have to be every single. It doesn't have to be installed in every single hotspot.
Yep.
But the idea is to have at least 3 to 4 secure concentrators, um, I mean, that it might even be overkill. But certainly for cities, having 3 to 4 secure concentrators, so you can get the
Oh, per
benefit of
city?
the. No, sorry.
Okay. I was like,
Per beacon, right? So like if a sensor
oh,
sends out
holy
a
smokes, that's a
beacon.
lot of them. Okay.
Well, actually, if you think about what the density of your average city is today, it's actually
Yep.
quite a few. I mean, what's in? I mean, New York City is probably an extreme example, but um, any given hex in Boston, where I am,
Yep.
there's at least 20 to 30 in one hex, and that's just crazy overkill. That we don't need that much redundancy.
All right. It is crazy. I
Hey,
mean, we got 2 Pauls on here. So Paul and Enlighten, let me square you away here. Disc 91.
hey, Paul, hey, Nick. Hope you're doing well.
Yeah.
Hello.
We're just talking, Paul Pinot, about the secure concentrator thing. So like well within this IoT range of stuff we've been talking about, and kind of some of the difficulties on it. So you need, let's say there's I don't know, like 10,000 hotspots in San Diego, which is way too many. But we're probably going to need 1,000, maybe 500 secure concentrators to make San Diego, let's say, like a secure city, if that's the way to think of it.
It's an interesting way of thinking. Yeah, I like it.
Yeah. Huh. Okay. And then what are going to, I actually am curious about the end cost. If we get to the place where you want to get, and these secure concentrators are out there in the world, I know we've talked a little bit about this, but let's hit it some more, is what's it going to cost for someone to upgrade, and what are they going to get for upgrading? And then I'm curious in the chat, like, is anyone out there kind of waiting for secure concentrators to come in so they can plug them into their hotspot?
Love it. Yeah. So let's see. Question number 1. What's it going to cost? I believe.
Yeah.
Right.
Yeah.
So I'm targeting under $200.
Okay.
I would really like it to be right around the average cost of a light hotspot. So, my ideal is that someone who is thinking about deploying a new Helium hotspot, they could basically have 2 options. They could get a light hotspot, or for about the same price, hopefully, they could get a secure concentrator, and then either upgrade their existing hotspot, or maybe even just get their hands on a Raspberry Pi. Getting your hands on a Raspberry Pi these days is kind of difficult. The Raspberry Pi is supposed to be like $35, but that's just not the
Nuts.
case anymore because of, yeah.
No, I saw a guy
But
on
maybe
Telegram
someday that
selling.
will get
You
fixed.
know
Go ahead,
there's
Paul.
a business where you buy hotspots that are defective on eBay, and you sell the Raspberry Pi, and you make money currently.
That's beautiful.
Oh,
Yeah.
I
So
like it.
that could totally be a thing that could happen. Yeah. Yeah. Send me your Raspberry Pi, and
Yeah,
I will send me your Raspberry Pi and some cash, and I will build you a hotspot and send it back to you.
Okay, because that's data only, so you can put it on the network, right? They're like, you don't need the HIP-19 thing for that. Huh? That's
Right.
an interesting thing. Um, okay,
What,
cool.
what what is interesting is, I mean, a secured concentrator is something really interesting, but we have to make sure that Helium network can continue to be used with standard hotspot also, even if they are just data only. But we have to make sure that it's not mandatory to have a secured concentrator, because it's better to not have a dedicated hardware in my point of view, because we want existing network to reach Helium. If not now, because it's crypto and frightening people and so on. In 2 or 5 years, we can expect that it's just going to be something normal. And the existing network could migrate to Helium and offer more coverage and so on. And for this, we have to make sure that they will be able to do that, not having to change the hardware or things like this. That's really important.
Yeah. So let's talk kind of compatibility for a secure concentrator. So the secure concentrator form factor is exactly the same as most hotspots today. It's just a mini PCIe. Actually, I have it right here.
I've got one on my desk.
Let me grab it. Yeah.
Really small, really small.
Ooh, okay, so a little Raspberry Pi with something on it. Yep. Yeah, cool.
Yeah, exactly. So that's what this is. This is my kind of like little dev. So it's a Raspberry Pi with a rack. This is basically just an adapter card.
Okay.
This is kind of like a standard part you can get from rack for like $15, and then the secure concentrator is right here, of course. So
Wait,
it's
no, hey,
this little
it's
mini
not, of
piece-
course, to me. Like, where does it point to it? What does this thing look like? This is all magic for me.
Okay, sorry. Yeah, sorry. My camera kind of.
Yeah, no, I can see it. I can see
Yeah,
it well enough.
that's good.
Okay, there we go. So you can kind of see it sitting right there.
Okay.
And so it's basically two screws, and then you
okay.
just pop this thing in. Let me get it to focus.
There we go. We'll get it. Yeah, send me one. I'll take some pictures of this thing.
Yeah, absolutely.
Okay, so we got a couple folks saying like they're going to buy a bunch of them, but we also have some questions, and I think it's interesting because you've definitely got the technical side nailed down. You're also working on the hip, so you have to think of kind of the economic incentive side. I know Max and I have been thinking about that. But one of the questions is why would someone upgrade if their setup is legit? Right, like I've got my thing on a mountain. I know it's there. I know it did a good job of putting it exactly where it is. Like, why would I upgrade?
Yeah. A couple reasons. I mean, reason number one is you'll get more rewards. Secure concentrators get 1.25x. At least that's what we're proposing in the hip. Reason number two is it actually provides a new type of location service. So secure concentrators use what's a technology that
TDOA?
actually exists in most. It's the time difference of arrival. It exists in most hotspots today if they had a GPS receiver. So it's basically you pair the GPS, the precise location of the GPS, with the ability for a secure concentrator to very precisely timestamp the arrival time of any LoRa packet. And then through the magic of math, you can basically triangulate where the beacon came from. So this beacon could have originated from low power sensors in the field. And this is very useful. TrackPack is using something like this today. Or it's not using time difference of arrival. It's just kind of using the RSSI to get a rough location. Using this time difference of arrival, I think it will get even more precise. So it's a benefit to the network. There's an added service that is provided.
TDOA is really interesting, and what is surprising me, I was seeing this as a killer feature for LoRaWAN. In 2016, something like this. But since I never seen it implemented, and I don't really understand why. I know that basically it really works well where you are outside cities because the radio wave are straightforward and the precision is good. But inside cities where your radio wave are rebounding between buildings, it's not good. But even, what I understand is that the precision is about 300 meter or about a kilometer, which is really good, in fact, because in the city or in the RSSI, you're more something like 3-4 kilometer range. So 1 kilometer or even half a kilometer is really good. But I don't know why this technology is not a lot deployed currently. Really surprising me. So really interesting.
It surprises me too. Yeah.
I think we're also going to see. Sorry, Siegfried had asked about this right there. So the precision, it sounds like from what Paul's saying, is that it's going to be. I got to figure out which Paul, how I refer to the two Pauls. Just 91 Paul is the kind of within 300 meters. I know that GeoNet is down to centimeter accuracy, and I think what we're going to see is both of these products kind of coming together and hitting this thing from two different angles. Because I don't think a network can be too secure as long as it's easy to use.
In fact, there's big difference between GPS and triangulation is a question of cost. That's the first one. The GPS is a $6 or between $6 and $10 component. and that can be the price of the whole circuit. So basically, you can divide by two the price of your tracker.
Yep.
So that's quite interesting. And the other reason is GPS is only working outside when the RSSI or TDOA is working indoor, outdoor, whatever. So that's, for that reason, it's quite interesting.
Hang on a second. So, because RSSI will get it'll change as it goes through a wall. So there's like a couple things that are problem. One is that you have to know for sure where the emitting sensor is, right? If the sensor, someone puts out a soil sensor and says like it's at some certain place, 32,117, whatever the coordinates are, you're trusting that is at the correct place. The same thing with a hotspot. And if I'm understanding it right, that's the weak point of trilateration, is that you're trusting all the other hotspots around you are where they say they are, so that you can figure out where you are, which is not necessarily true, as we've seen gamers on the network. And even, I mean, I've talked about this. I think it's a problem for privacy reasons. The very first hotspot I put exactly where it was. And then I had people driving by the street to look at my house, which is like, I don't mind. I like meeting people, but that's not for everybody. And so there's a privacy concern with making sure that, hotspot is where it says it is, but it's also something where you don't have people knocking on your door if you don't want it.
What is interesting with Helium is, I mean, when you do RSSI positioning, you don't have to understand that when you are really close to the antenna, if you touch the antenna, we can say that somewhere you are positive RSSI, like 0 dB or
Yep.
potentially 15 dB. Okay, that's something you can get. But if you go 1 meter, you're gonna be minus 30.
Okay.
If you go 10 meter, it's going to be minus 80, for example. So
Okay.
it decreases really fast, okay? But after, if you do 1 kilometer, it will be minus 100. If you go 10 kilometer, it will be 110. If you go 40 kilometer, it's going to be something like 125. So what I mean is triangulation is really precise when you are really close to the antenna,
Yep.
and really not precise when you are at a long distance. And what is really interesting with Helium is that it's an ultra dense network. So you have a lot of chance to be at something like 50 meter or less than 100 meter of a getaway. And so you can really get a really precise localization. In fact, that's really quite interesting compared to standard network where you are more than 2 kilometers from a getaway. And basically, if you have a variation of 5 dBm on your SSI, it's something like 10 kilometers. So that's really interesting, and that can help to get something precise thanks to the number of getaway or hotspots you have all around you.
Dig it. Yeah, we may be able to overwhelm this thing just with numbers, the sheer numbers of hotspots out there. Okay, so these things are going to be $200. You're going to make 1.25 or 1.5, or if I had it my way, 5 or 10x, because I think it is super important. But I'm sure I'll get shouted down on that one.
And yeah, just to make the link, there's a lot of questions about GeoDNet on the chat.
Yeah.
And just to make the link, GeoDNet is not to achieve 1 meter with a GPS. It's more to go to 1 centimeter. So it's a scale change for GPS.
That's right. Are they sending you a unit yet? Have we sorted that out, Paul?
Yeah, I got a unit. I will install it this weekend. I found a rooftop to put it. So
super cool. So we're gonna get it out in a French video, because I think that's the thing that's crazy, is that France is super resistant to any of these crypto projects.
Yeah, to any crypto project, in fact.
Yeah. Okay, cool.
No, yeah, that's super interesting project. I mean, if we have companies that do this kind of stuff, but they are more national companies. So you can have information in France, but if your device is moving to Dutchland or UK, you will lose this info. I mean, the precision will be lost.
Yeah.
Through the ODNet, you have a global network, and basically wherever you are, if the network is dense enough, you could have a really accurate location. And that's interesting for industrial projects. I mean, like imagine you are an automotive constructor, and you are selling cars everywhere, and you want to have a high precision positioning of the car, which is really important for autonomous driving or even driving behavior. Basically, you can rely on a such network. That's quite interesting.
Yeah. Love it. Enlighten Paul. Let's see. So when these things come out, when these secure concentrators come out, I saw a couple of people like, hey, where can I, send my Pi to? Like, how am I going to do it? Is Enlighten going to be selling them? Is it going to be a Helium Enlighten thing? Like, what's the plan for how people kind of get these things or order them?
Yeah. So I am planning to sell them through my website. And I've said this many times before. The plans are open source. My goal is to improve the network by, advocating for secure concentrators. And yeah, I want to sell them, but I also would love for other manufacturers to make this thing and sell it. And I realize that by saying that, it's going to drive down the price of a secure concentrator, because when companies compete, how's that go? Companies compete, you win as the buyer of the thing. But I think this is a good thing for Helium as a whole. I'm just kind of hoping that I'll be able to be the first, and people will want to buy it from me. And then, well, I guess we'll see how it goes. So yes, so I will have, yeah, and everyone will yeah, exactly. So I will have my website hopefully ready to take orders when the time comes. And I also hope that other manufacturers will do the same.
Yeah. And I think this is the other question I just saw from WTV. Can you take a secure concentrator, this is going to sound so stupid, and just like plug it into a hotspot through like a USB port on the Pi and all of a sudden make it a secure hotspot? Or is that not possible yet?
That is a cool idea, doing it through a USB.
I'm sure there are significant flaws with it.
Well, no, because the security of a secure concentrator is contained to the thing itself, right? It's contained because this carrier board, which has both the radio and the secure microcontroller on it, is on the same PCB, and is resistant to tampering. You could put this kind of externally and hook it up through USB. That might be a cool like kind of little side project to make a little adapter board. And this is the beauty of open source, right? Because when this thing comes out, other people are welcome to, if that's a cool idea that you want to do and you have the knowledge to make a little USB adapter board, you could do that. All the everything you need to interface with the secure concentrator is open source, and so you're just welcome to do that.
Disk 91, Paul, what do you think? Are we going to see Disk 91 secure concentrator USBs? Are you going to manufacture that? It's outside of.
No, I was thinking about PCI Express there is different standard, and one of the two standards is USB, I think. So basically, it could be quite native.
It could be quite what?
Quite native
Okay.
for such board to support USB. What I think is, my point of view, hotspot should not be a Raspberry Pi. Hotspot should be an embedded microcontroller. Like we see on a standard LoRaWAN gateway, and so USB is not a feature you need in a such context. So that's probably not something really important. But we also have a large community of hacker or maker that have Raspberry Pi and basically want to make their own hotspot, and so it's interesting to propose them a way to make their home hotspot and come back to the DIY system. So it can reduce the price because you just have to buy the concentrator, and also by doing it yourself, you learn more, and you are happy to discuss about it, to experiences, to show it to your friend, and it's good also for increasing the network size. So that's quite interesting.
Yeah, I love it. My brain is is reeling with this kind of new idea. Who thought of this? This was
It wasn't
come
me.
talk to me.
Yeah.
So Paul, you say yes, a hotspot should not be a Raspberry Pi. Totally agree with you, right? Raspberry Pi is totally overpowered for the requirements of a hotspot. But I'm going
And
to go the
fragile.
other direction, right? So imagine this idea of an adapter card that takes a mini PCI Express and routes it out through USB. You could then turn in your desktop or your laptop to into a secure.
Yeah. What
Yeah,
what I don't really like with this is, I mean, we are building a network, and so we need stability. The problem I see with Raspberry Pi is that Raspberry Pi are fragile. On my hotspot fleets, I mean, I spend some hours to unsolder embedded flash on Nebra to resume them and that, and because they are much more fragile than a classical embedded system. And currently, we have a 900,000 fleets of hotspots that has been registered, but we have something like 400,000 that are really active on day-to-day basis currently. Part of this, we have 200,000 of cheater, but we have lost something like 200,000. And in my point of view, there's no interest for someone to disconnect the hotspot because, I mean, it consumes nothing. So basically, if you have installed it, you have no reason to remove it. But if it crashes, you won't pay to repair it. So it means, in my point of view, that the 200,000, they are just dead units. And if you have an embedded system, I mean, I have since now about 8 years, I have gateways that are working on TTN or standalone on the field, and I had no issue with them. I mean, the hardware is really, I mean,
Oh,
industry
really?
grade.
So they're rock solid. Okay. So
Yeah,
okay.
yeah,
Huh.
that's one important point. And what I mean behind this is, if you use your
very good
desktop
point.
by putting something here, it means that you're gonna stop your desktop at night, and you shut down the network on your cell at night. This is
Yeah,
not what we want. We want
Right.
something which is stable, we can trust.
it's a good point. It's a good point. Yeah, yeah. There's nothing better than well-designed embedded system for doing a very specific task and to do it right and to do it for many years without needing maintenance. So, good point.
Huh.
But where it makes sense is, I mean, there is some use cases that are really interesting with such situation. Like, I mean, you are a professor and you want to learn and law one to your student. You don't have a lot of coverage. You cannot install a gateway on the rooftop and so on. Okay, just plug a concentrator on your laptop, and yeah, it can be quite efficient in terms of price and really fast to deploy. Usually, I mean, what we do is using a standard AP, but you need a 4G connection or Wi-Fi. Or it's a setup that can be complex. So if you can plug it on your laptop, run a Docker container to make it working, yeah, that can be really, really simple and help DIY student and things like this. So there is application for this. I just mean that in my point of view, it cannot be a standard of deployment.
Options, right? I mean, I guess because secure concentrators could pop on and offline. Like the fundamental thing that they do is they basically kind of validate a beacon, if I'm kind of wrapping my head around it in the right way. So as long as you've got a couple of them out there on at any one time, it could be, you could have both ways, right? The embedded system that's going to last for 10 years and is in a place that like always going to work, super reliable. And then you could have folks, I mean, it's interesting to think about, what if this thing is on a little USB and I'm flying around the country meeting people and I just plug it into their computer for 12 hours, validate a bunch of the beacons that go out over that 12-hour period, and then I unplug it. I'm sure most people would not be comfortable with that. But kind of go to the next place. Like it'd be almost a spot checker in the same way that we used mappers early on.
Yeah, I like it. I like it.
So
Very
FPGA,
cool.
was that field programmable gateway something?
Gate array.
Gate array, okay. Are way more
Yeah,
expensive than our
gateway.
Pico. All right. Yeah. I I mean, I think as the network matures and goes from a thing that was kind of like a, hey, let's see if this works, to a holy shit, this thing is all around the world and people are relying on it, we're going to see significant changes in the gateway numbers. I mean, I'm thinking that we're going to see gateway numbers drop down to the 200,000 kind of number over time, where you get the folks who are actually using the network saying like, hey, I need this thing up, versus the people who came in, you know, early on to make 10 grand a month on, you know, 9 gateways in their bedroom. So, yeah. Let's see. Well, that's a pretty decent secure concentrator update, dude. Good work.
Yeah,
I guess the last thing is like,
lots more to come.
Yeah, when is it going to be ready? When secure concentrator?
When secure concentrator? Yeah, hopefully soon. You know, this is kind of not the thing that you want to rush. You know, the worst case scenario is we rush the hardware or the software. Well, the worst case is that we rush the hardware and it turns out there's something wrong with it. So, or, you know, there's, you know, it can be hacked or something like that. So, so yeah, so we definitely want to take our time. I'm working, you know, with the MCC. They provide great feedback, and sometime this year, I think.
Okay, 2023. We should see it.
Yeah.
Super cool. There comes my mom with the green drinks. She's been making me these little green smoothies. She's in town staying with us for the week. So that's like every
Thanks,
morning
Mom.
right around 9:45. In comes the green smoothie.
I see a question on the chat about spoofing packets with secure concentrator, or basically saying that it's difficult to do with a secure concentrator. I missed the beginning of the talk, but did you explain, I mean, the difference of having the secure element inside the concentrator versus having the secure element on a doser board where you have also the standard concentrator?
Yeah. Yep. So you can definitely read more. There's lots of gory details in HIP 72, but I'll try to kind of give the overview. So the idea is that we've moved the secure element. So if you think about your standard hotspot design, the way it works is you take an off-the-shelf, what do you call it? Off-the-shelf concentrator card. You pair it with a Raspberry Pi and a custom PCB board. That custom PCB board has a secure element on it. And secure element is just a fancy word for a little chip that has a unique crypto key in it and has the ability to sign or encrypt anything that you send. And that's actually kind of the problem with the existing hotspot design is that because that secure element exists on the PCB board, I call it the carrier PCB board, the software is free to ask the secure element to send to sign any packet it wants, including packets that were totally fabricated by the software. So that's bad, right? That's how people cheat the network. So the idea with the secure concentrator design is to move that secure element onto the radio board itself, and then package it in a tamper-resistant way. That makes it very difficult to physically gain access to this thing. And I would also say, importantly, it it's on the same PCB board, so it goes wherever that goes, right? So you could take it out of a hotspot and put it in a new hotspot, and your security goes along with it, right? Like, so yeah. So hopefully that kind of answers the question. It's a little bit difficult, and it's kind of like. It seems like a small change, but I think it's actually a really big deal.
Yeah, sure, it is. Yeah, okay.
Okay, well, if this is the way that you attack this stuff, I think it's one of those things that I thought you were very careful to say it's tamper resistant, not tamper proof. but I'm guessing that most people aren't going to be doing whatever this is, millimeter wave fault injection. I'm not going to be fucking with that. I'll tell you that.
That's right. And the
Question, yeah.
yeah, and I want to set it up in a way. Well, so it is designed in a way such that if you try to gain access to it, so it's in potting. The potting is very hard. If you try to scrape the potting away, you risk actually like physically breaking the chip. If you try to, well, I won't give away all my secrets, but
Right.
let's just say you risk destroying your crypto key, and you eventually will have a brick that cost you less than $200.
Yeah, and what is important in security is that, I mean, security is something which has a non-end things. But the question is how many dollar do you need to spend to break the security?
Yep.
If you are spending more money to break the security that you can earn by doing this, there's no gain. So someone will do it, but we don't really care. In fact, that's what is important here.
Yeah.
Yeah, that's a great point. Like security is a spectrum, right? There's no, is secure yes or no, right? It's
Exactly.
but there is more secure or less secure, right?
Yep.
Like so basically what I'm trying to do is move the needle to make the hardware that runs the Helium network more secure.
Right. And I guess that's a good point, or a good, like, there's a really strong upside for HNT to be lower in price, is that it makes it much less worth it to try and hack it. So that's the upside of all of us having ridden it from 55 down to 3.
Yeah. The negative point is that it's also why, I mean, when your hotspot is just stopping to work, you are not specially investigating and trying to repair it, which is also a big issue in my point of view, man. That's the 200,000 we talked previously.
Yeah. Cool. Super cool. Yeah. Anything else? Disk 91, Paul? We were going to talk about LoRaWAN devices and getting them on and kind of what's out there and how to find stuff. I know you've been in this game way longer than I have. Like, when you're looking for a new device, is there a company or a website that you're going to?
Yeah, I mean, there's different category of devices. The first category is not really devices; it's looking for a service. Like, I mean, you want to measure your CO2 or something like this,
Yeah.
or take the example of you want to have a weather station. Okay, so you can go to a service things like 𝗪𝗻𝘁, for example, or 𝗪𝗻𝘁, sorry, which is another project where you get a device, and basically it's a service. I mean, it uses a Helium, but you don't really care about this. You have a device, you have an application, and okay, you get your weather information.
Yep.
The second kind of devices is you want to buy a device which is ready to be used, but this device is just delivering packet of data, and you have to connect this to your console, and then you have to build the application for seeing this data and getting your information, which is good. I mean, if you are a developer and want to investigate stuff, I mean, that's quite interesting. But if you want to fill your hose with a sensor, yeah, you're gonna spend a lot of time. That's
Yeah.
good. For this kind of device, you have plenty of shops where you can find this, because this is really the classical way people do in the industry. So, I mean, you have 1,000 of different devices. You can get on C, you can get on rack, you can get some in specialized shops for IT device. What you have to do is every time you have to find the documentation, understand how the data is encoded in a frame, decode it, and doing your implementation, your dashboard, and so on. That's really funny to do. So, okay, but a little work. And the third type of devices is more dev kits. So you are just buying a microcontroller with a transceiver, basically, and then you are connecting your sensor and you are integrating all that stuff. So you also build the device, and then you have to manage the connectivity and the application. So it's really your device maker, basically, doing everything. And for this, shop like 𝗀𝗲, AliExpress, Rack with WizBlock are really interesting solution, as it's kind of Lego where you plug the different devices all together, and you make your own solution. So basically, it's where I'm going. I mean, I'm going to Rack, 𝗀𝗲 most of the time, and AliExpress
Yep.
for another part, Amazon sometime. Yeah,
Yeah.
this kind of jobs.
Okay, that's a good way to think of it. As you were talking, I was wondering, Paul, at Enlighten, are we going to see secure concentrators go into sensors, or does that not make any sense at all? So that you
We have a lot of secure element in sensor. Yeah, we have a lot of. But in my point of view, it's just stupid. But that's my point of view. I mean, it's if you are a military business, makes sense. For the rest, well, I mean, if someone is physically attacking your device to steal your keys, I mean, it means that he has a physical access to the device. So if I have a physical access to the device, I can do what I want on the device. If it measures temperature, I will just put another device measuring temperature just close to it, and I will get the same data. Okay, and so
yeah.
yeah, that's my point of view. It's not something really. It has an extra cost, but. When I say that,
Yeah.
everyone in security would say, that's a stupid point of view, but that's my experience.
Yeah, I agree. I think what we might see is uh, is is secure mappers of some sort. And I don't know if that needs to be a full secure concentrator. Like, I don't know if a secure concentrator is the right hardware to build secure mappers out of. It might not be, um, but I'm excited for what's to come in 2020, and
Yeah.
I think we can see these types of new cool devices like mappers coming out soon.
And yeah, I think there is something really interesting to do with GeoNet, I think, because I mean, the problem of GPS is you can spoof the GPS. I'm not an expert of this, but I assume that if you to spoof a GPS, you need to have the ephemeris of the zone you are going to spoof. But I don't think that if you are really at this place, this will match with the data of a GeoNet network that are really secured. And I'm not exactly sure, but I think that there is something to do with this, with validating the GPS data thanks to this.
Yeah. Huh. Cool. I mean, we're going to see the growth and the maturation of the network. It's pretty interesting to kind of look back and see where what TTN has done for LoRaWAN, and then look forward and see what Helium has also done and kind of will do, and where all these things go and come back together and make the whole thing better and better and better, because there are significant benefits to both sides. Pretty cool stuff. Ripping. Well, that should pretty much wrap it for the week. Is there anything else that you guys wanted to hit? Have you guys, Paul? I know you're in the U.S. Have you tried the eSIM thing, Paul at Enlighten?
No, I would love to.
Okay.
Yeah, very exciting news coming out of there.
Yep. I think that's just try.heliumsim.com. I think that's it. I put one on the phone yesterday. I was hoping to see Helium kind of pop up on the side of wherever the top right of my phone corner piece, just so I had the label and I could take the fancy screenshot like all these guys are doing, but I couldn't figure it out. It just shows two separate bars, and the bars on the bottom show one, I guess, carrier, and the bars on the top show the other. So
You have to give me the link, Nick. I will be in the US in 2 weeks for the LoRaWAN conference, and
okay.
so I would be happy to give a try to LoRa 5G in Florida. Yeah.
Yeah. Heck yeah. That'll be cool. Let's see. So my Stefan, what about USB sensors that plug into a hotspot? We hit that a little bit. I think that's maybe there's something interesting there, maybe not, but pretty cool stuff. I don't think there was anything else big that I saw in Helium. I know there's the 1663 folks at Nova are doing something in Berlin pretty soon next week, doing the first kind of international LoRaWAN thing for Helium. So that'll be interesting to see how that goes down. And then there's the ETH Denver. I know there's a side event there for some deep in stuff. I thought I was going to be there. I don't think I'll make it out there. But yeah, kind of pretty wild time to be alive as people figure this stuff out. So
Absolutely.
cool, ripping. Well, thanks both of you for coming on. Super excited always to see kind of technical experts come in and share what they know and their perspectives on this, and really cool to kind of hear about the secure concentrators and to think about how all of those different things might work together to make the Helium network better. So thanks, guys.
Thank you.
Thanks, Nick.
All right, guys.
Thank you all.
See ya.
See you next week.
Good.
Ciao.
Bye.